All right, let me share my slides now. OK, donc, aujourd'hui, on va parler du data engineering dans le cloud. Donc, data engineering dans le cloud et plus spécifiquement avec Google Cloud. Mais
Désolé, tu veux faire en anglais peut-être? En ce moment, tout le monde parle anglais.
Tout le monde parle anglais. All right. So today we'll talk about data engineering in the cloud, basically.
Désolé d'interrompre. Il y a une personne qui vient de joindre et le nom c'est Akuba. Donc, je ne sais pas si la personne parle anglais.
Elle parle anglais.
Yeah, she's
Okay.
English very well.
OK. Je voulais juste...
Oui, je comprends.
Okay.
On connaît qui est Akuba.
OK. All right. Go ahead, please.
Yeah, thanks. So basically, data engineering in the cloud, and more specifically with Google Cloud. But in reality, if you know data engineering in one cloud, it's fairly similar to any other cloud or even on-premise. And on-premise means on company servers, basically, like physical servers. So what is data engineering? And it's in French, so I'm going to have to think about it in English now. And thanks to Ben for that. So data engineering basically is this field that came up from like old school ETL, where you basically build pipelines for companies, right? So for example, in the past, like when you will call an ETL developer, so ETL stands for extract, transform, and load. So basically meaning that you extract the data, you transform the data, and then you load it into another table or another location. So then it turns out that later on, didn't ETL developer kind of like the name changed to become data engineering because of the whole thing about big data growing and machine learning and data science being so popular, right? So data engineering is also a subsection of data science. So let's say you are a data scientist and then you are prepping your model, prepping your data to fit it in like a model, for example. The steps that you do to get the data prepped, pulling the data from somewhere, putting it into a table, doing the transformation, the feature engineering, all those steps up until you actually do the modeling is technically data engineering, right? So that's kind of like the overall definition of what a data engineer is or does. I wanted to show you trends on how I have some statistics that I pulled that I wanted to show you. So if you bear with me here, I will show. Anybody on the call is a data engineer or has done data engineering in the past? Or okay.
Yeah, I've done a little bit of ETL some years ago, but it wasn't called data engineering then.
Yes, it wasn't. Yeah. Okay, let me know when you can see. So we'll use the US kind of like as a, I don't know, like way to do the statistics because I don't have the statistics for outside of the US. So basically, the demand for the job has grown pretty much for the past, I don't know, between 2018 and 2028. Like they see that there's going to be a 21% increase in that demand for the job, right? And they say that the average salary for a data engineer in the US is about 109 grand. currently there are about 4,000 data engineers, but I'm pretty sure it's probably a little more than that, because you could be in a company with a title that is not data engineer. They can give you a software engineering title, even though you're doing data engineering work. So you could have more data engineer actually in the US. And this kind of shows the progression in terms of like the demand, the jobs. This is probably like, I'm not sure what happened here, but there was a decrease and then it's picking up again. I think, yeah, sorry. Apparently, like the most common cities for data engineers, Annapolis, which is that Virginia? Which is kind of like surprising, because I would have thought that places like California would have way more data engineers, right? Because you think about Silicon Valley and all these big companies, they hire a lot of data engineer to basically like work on their data, get it prepped, to do a lot of their machine learning and deep learning and AI stuff. So
don't forget, the government likes to know about people.
That's true. That's true too. Yeah. So most common state for data engineer. That really kind of surprised me, but whatever. Okay. I mean, it's data, I guess. Number of data engineers by state. You can see California, 13,000 openings, 2,000 here. So yeah, and I'm pretty sure like these numbers are similar in Canada as well. Again, I don't have a lot of visibility in what's happening in, let's say, for example, in Burkina or in Africa. So if anybody has some insight in that, that would be most welcome. All right, so let me continue.
I'm sorry, can I jump in with a question?
Sure.
I'm sorry, gentlemen, you'll get to know I'm a very curious dude, so if I'm wasting your time, do let me know.
No.
I'm interested. I see the projection. I'm interested in what's your opinion with AI and ChatGPT. I'm pretty sure someone out there is working for an implementation that will slice into this particular job, just the way it is. I'm wondering how you gentlemen thinks that will be affected. Is the projection more? Is it less? And what can one do to equip themselves of that coming change if it indeed affects this type of job?
If I understand your question, so you're asking how ChatGPT is going to affect like
not ChatGPT, I'm asking about AI per se. ChatGPT is an example. I'm asking about AI because in my mind, I think there may be an implementation that affects the space. If that's wrong, do let me know. But if it does affect that space, I'm wondering now it's about adaptability, right? Because if I'm learning that skill, I might need to know where it might be in those couple of years, or else in 5 years, I might find myself outpaced yet again.
Ben, do you want to start, or do you want me to start?
Yes. So I think the solution to that is to level up in terms of skills. Because all this stuff, AI, I don't even like the term, because it's just machine learning. That's really all it is. So the solution, like I was saying, is to level up, to learn at least the fundamentals of machine learning all the way to deep learning. At least knowing that, it's easier to pass out all this information that comes like every week about all these fancy tools, and then realize that it's nothing magic.
Fair enough.
Yeah, because there's a difference between, okay, so in that field, right, most people are on the user side, meaning that a restricted group comes up with the new algorithms, the new techniques, and then most people, especially engineers, are on the consumer part. Basically, they pick a framework and they use that without actually knowing what it does behind the scenes, right? So what I'm suggesting is to start learning the other side, like how to come up with frameworks like this in the first place. That approach will be future proof, I think.
Yeah.
I understand. Thank you.
And just to add a little bit more to that, and it goes back again to kind of like having that generalist mentality where, like, as opposed to kind of like seeing a change come and look at it as like a, how do I say that, as a risk or an issue, you embrace that and then you just write it basically, right? So ChatGPT came and it writes code and it does all these things, but in reality, I mean, I was gonna say the thing, makes mistakes. The thing is powerful. Don't get me wrong, like, right? But I, instead of like looking at it as a threat to my job, I actually use it to be even more productive in my job. So I'm like faster in like doing things and stuff. So I mean, the rest you can't really control. What you can control is just how you see it, how you adapt to the situation, and you know like skill up basically. Like in our field, you always have to keep like skilling up, like learning new things, learning new ways of doing things. So yeah. Any other questions? All right. So basically, um, like the data engineering, like what are the steps that a data engineer would basically go through to, get his or her work done, right? So, and the process itself is um, like building, like I said, at the end of the day, building like data pipeline, right? So um, in that field and in those steps, like you have the capture, so meaning um, getting the actual data from a place. So the data can come from, and I will touch on that in the subsequent slides, but the data can come from IoT devices, other companies, your own company. So basically different areas where the data can come from. So then when the data comes into your own environment, you have to process it, right? So when you process it, you can do data cleaning the data, transforming and making changes to it. So for example, like do some calculations. And then once you're done with that processing, you have to store it somewhere. Typically you store it into a data lake or data warehouse. And then once you're done with all that, you have to analyze it, right? You have to be like, because what's the point of getting the data if you're not going to use it? Oh, sorry, if you're not going to do something with it, right? So you analyze the data, you ask it questions, you find insight, hopefully, and then based on those insights, you use the data, and then you what's the word I'm looking for? Um, what's the word I'm looking for? You basically like apply it into your company, meaning you find an insight in the data, then you make here you go, you make your decision, right? You make something out of it, right? So, any questions? Okay. So in terms of Google, how Google is concerned, is this slide? Can you see well? It's not too small, I hope. Let me see. I think it's good.
Yeah, maybe you can zoom in a little bit.
Okay. Come on. No. I don't have my mouse with me, so it's kind of like. Is it better? Maybe.
I think it's okay.
All right. So in terms of how Google is concerned, these are the steps, right? Like the capture, process, store, analyze, and use. So the tools that they have to capture the data. So you have, I'll just say the tools, but like I said, any other companies will have similar tools. So you have, for example, PubSub, which is kind of like a streaming tool. So in essence, when you have data coming from telemetry and IoT devices, like for example, your airplane engines or windmill turbines and all the things that are creating data like continuously. You can come in through PubSub and then eventually land into sort of like a data warehouse. You have ways to transfer data from a company, from one company to the other, and then like I said, I was talking about the IoT, IoT, which is Internet of Things. Those also can create the data for you. And then you have your data warehouses, so your data processing framework. So you have Spark, which is one data processing framework. You have Dataflow is another one, which is a Google tool, and Data Prep, which is another Google tool. And then you have the storage. You have cloud storage, which we will touch on later in our demo. And then you have BigQuery, which is a kind of like a data warehouse for you. No, sorry, this is BigQuery storage, and then this is the actual analytical engine. And then you have BigQuery, the actual analytical engine, which is kind of like a query tool, and we'll show that in our demo. And to use it, you have the different AI tools that Google provides. So you have Cloud AI, you have Looker, you have TensorFlow that you can use to do your deep learning, and you even have like tools like Vertex AI and things like that. So this is an example of a pipeline that any company could have, right? So the way it goes is that you have like real-time events. So you typing something on your phone or whatever, right? Or doing something, then the data is captured here and sent into this app engine. And then, as I was mentioning before, it's like real time. So the app engine then sends it into PubSub. And then that data now is in PubSub. Then you have what you call a streaming pipeline, which is basically streaming means that the data is coming in kind of like how you watch Netflix, right? The data comes in like continuously, right? And you have Dataflow, which is a data processing tool, which basically processes the data as it's coming, right? And then when the data is processed, it puts it now in BigQuery. And then BigQuery, as I mentioned, is your data warehouse or your analytical engine. And then once the data is here, you have tools like Tableau, which I'm sure some of you have heard of, Looker, Google Sheets, Data Studio, who can now use this data to look at, find answers to that data. They can query it, which will show the demo. They can do processing, not processing, sorry, analysis from that data. So I will touch on a little bit on, so I talked about streaming pipeline. You also have batch pipeline. So the difference between streaming and batch, so streaming, as I mentioned, is continuous. So it's always processing. It's always doing the
conveyor belt.
Yeah, exactly. It's kind of like a conveyor belt. Yep. So it's always processing the data as it's coming, as it's coming, as it's coming. Whereas batch means you have it scheduled, right? So you can have a batch job which starts, let's say, every Saturday morning at 7 a.m. And then with whatever data is there at that time, it processes that data, and then you won't have the next one until, let's say, the next day, for example. So it's like once a day, twice a day, so that's kind of, it's more of a scheduled way of processing the data. So batch versus streaming. Any questions? Okay. So going back, so basically we'll go through these steps right here. And I'll kind of explain them a little bit. So the data collection, right? So how do you collect the data? So as I mentioned, you can collect the data in various ways. So you can get it from other databases, you can get it from other companies, you can get it from IoT devices. You can get it from social media. So anything you can think of, anywhere you can think of that data is created is a source of data, basically, right? And once you get that data, it needs to be, first of all, validated. So there's some data quality checks that happens. And then you basically have to also clean that data. That happens in the subsequent steps. So that's the first step, like you need to collect that data. So you need to, first of all, find where the data is coming from and basically get it. And there, in an example that I can give, let's say you are a company, like a company, and then you need data from another company, right? There are two ways for you to get that data. You can go, and you have to obviously talk to that other company and set up, ways to connect to the server, to the computers, and pull that data into your computer. So you can do it in one way where you actually go and then find the data. So it's like a pull mechanism. So you connect to the servers and then you get the data from them, and then it lands into your own servers. Or the another way is more of a push. So the company that is outside will send you the data in your servers or in your company, right? So those are usually the two ways that I've seen. Ben, I don't know if there are other ways that maybe I'm not thinking of, but so basically like a pull and push mechanism. So you pull the data from them, or they push the data to you. Um, let's see. Then you have. Actually, I didn't want to show this one. Let me go to the next one. So then, if you go here, we're now in that step here, process. So once you have the data in your company, the data comes in as you call raw. So it's a raw data, right? So a couple of things you need to do. First, you need to make sure that you got the correct data. So you have to do some data quality checks, making sure that, oh, they were supposed to send me a data that's like 2 gigs or 300,000 lines of 300,000 records. Make sure that you actually got the full data. So like I said, data quality checks. You also have to do let's say you need to do some calculations, right? So if it's like sales data, for example, right, then do you need to compare it with like last year's data? Do you need to calculate variances? Do you need to calculate averages? Do you need to calculate profits and things like that, right? So this is the step where you do your processing, right? And typically, like I said, you could do it in batch mode or in streaming mode. And some of the tools that, again, you can use to do that, like I said, Spark. You can also use some SQL to do that. Or you can also write Python or R code to do that as well. Any questions? Then once you're done, so let me go back up again and then show you where we're at. So we did capture, we did process. Now you're done with doing your processing. Now we need to store it, right? So when you're done with your processing, you need to store it somewhere. So a couple of areas where you can store it. So you can store it in a data warehouse. So as I mentioned, BigQuery is one from Google. I can't remember the one name in AWS, but AWS has a version of a data warehouse as well. Microsoft, so many companies have their version of data warehouses that you can store the data. You can also store the data in other types of storage. So like, for example, HDFS, which is kind of like a Hadoop, which is an older version of an older tool that we used to use about 10 years ago. It's a way to store files. S3, which is Amazon's bucket, where you store files as well and objects. Microsoft Blob Storage is similar to S3, and Google's version is called Cloud Storage, which I will show in a demo. So that is the storage part of things. So you've gotten the data, you've stored it, you've analyzed it. You've processed it. Now you store it somewhere for use.
Yeah, maybe you can mention what's the purpose of the processing at the beginning.
What's the purpose? Right, so that's what I was mentioning, right? So the purpose is to, a couple of things you can do, right? You can do some data quality checks there. You can do the transformation, right? If you need, because like I said, the data can come raw, and then you need to do some a transformation to maybe find like let's say I was using the sales data, right? So the data might come in from let's say, and I'll take another example, right? Let's say you have a bunch of gas stations. Think about BP, for example. And BP has like thousands of gas stations, right? Every day, each of these gas stations sell gas, they sell snacks, they sell a bunch of things, right? Now, every night, these POS systems, these point of like the registers there, they send data, let's say, into BP's headquarters, for example. That's just an example, and it sends it into a let's say like a as a file. They send it into like a storage, for example, which could be like a bucket or a S3 bucket. Then the data, again, like I said, comes in raw. So you get the sales from stores in Connecticut and Michigan, blah 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 blah. It comes in raw. Now, as an analyst, let's say you work for BP and you're an analyst and you want to see how much sales have I made BP in general, how much money have we made like yesterday. So you need to find a way to add up the sales from all these companies, all these stores, right? Gas stations all over the country, right? So that's where you do the transformation. You need to like load the data first, clean it up, and then in your processing is where you can now start doing the calculations that I'm talking about. So you need to like, for example, say, oh, add all the sales from all the stores, right? Calculate the average for average how much, for example, this diesel fuel have I sold in, I don't know, the West Coast, for example? How much candies of this particular brand have I sold? So you then start to like do these little calculations which happen in the processing so that the data is prepped for the next step. So I don't know, Ben, was that what you wanted me to explain?
Yeah. Because I wanted to I wanted the audience to have a better idea that the data that comes raw is not clean.
Yeah.
Like there might be some entries missing, some columns missing, and the processing step will patch for that, so that after the processing step, it's clean data.
Yeah. So I don't know. Did it make sense in terms of the example with the gas stations? I would take silence as yes. Byron, you have a question?
Yeah, I just wanted to add on what you say. Sometimes we also use that step for data sanitization. For example, you load data and the dates are in the French format, but the actual computation needs to be done into English format. So you can use that step to format the data in the correct shape. You could also load data which comes in as comma-separated values, but for the purpose of the application, the data need to be like on the JSON format. So you can use that step to format the data in JSON format. So this is another use case for that step when loading, transforming, and storing data.
Yep. You brought up a good point. The date format is is a pain. It's working with dates, and maybe folks may not know what we're talking about. So I'll just give you a quick example here.
There's dates also, postal addresses.
Yeah,
it's painful, like phone
Yeah.
numbers, all that stuff.
so where is my okay? Don't mind me. I will change something here. So for example, let's say you have the date in so 2023. What is today? April 04, 22. Right. So this is one format of data, of the date. Now, sometimes you may want it to be 04, 22, 2023. Right. So you go from here to here is where you can do the data processing, basically, the data processing step, like to go from this format to this format, or it can, and the date can come in so many different ways, right? And you have to find a way to like transform it to the way that the user wants it, or how another tool might need it to be, basically. So that's what Baron was talking about.
Yeah, there's also like corner cases, like the first date you wrote.
Mhm.
Sometimes it's flipped, so it will be 22/04, 2023. And
Yep.
in case of 22, it's obvious that 22 is the day, right? But what if it was 04/04, 2023? Like, how do we know which one is the month, which one is the day?
Yeah, if it's like this, it's hard. You have to look at other dates to know what the actual format is, right? Yeah, so you have to do a little bit of digging. That's why I don't know why Americans like to, anyways, I'm not gonna get into that. Any other questions on this? Ça va, Achille, il n'y a pas de souci, c'est bon? Okay. So when you're done with let's say the data is now stored, right? Again, sorry to go back to the top here to kind of tell you where we are. So we did capture, we did process, we stored it. Now we want to do some analysis, right? So the analysis can be done by multiple people. So it could be done also by a data engineer. Data engineers can do some analysis. However, it's not a whole lot, especially not in my experience. Like, we don't do a lot of the analysis per se, unless you work with a lot of data scientists. So, but the data is definitely used by analysts. So like analysts, which we call on the business side. So the one who actually need that data, right? So analysts might come in once, again, I'll use the gas station example. The data came in at BP, it's been cleaned up, it's been processed, and it's now stored in a table somewhere. Now the analyst comes in and then start to write queries to ask questions to that data. Again, the example that I used was, hey, how much M&Ms have I sold last year? I mean, sorry, not last year, yesterday, for example. How much diesel have we sold in California? How much hot dogs have we sold in the convenience store of the gas station? So then that's how you know that information is because the data came in, it was processed, and then it's in a nice format now for you to start doing the questioning. The other thing that you can also do is actually put it in, have dashboards be built on top of that data. So dashboards, the tools that you could use are Tableau, Power BI, Quick View is another one. You can also use Python and R to create dashboards. So usually the dashboards, again, are used by either the analyst or someone even higher up. So like VP, for example, vice president doesn't want to come in write queries. He doesn't need to. Vice presidents usually don't get into the nitty gritty of the data, right? So they need dashboards because they need to see the result quicker, right? They can like compare things. So that's where someone like an analyst could build a dashboard for, let's say, someone else in the business, like a senior vice president, a vice president, or CEO, things like that. Yeah. So I think next one is, so what are the skills? And again, this is an introduction to data engineering. We wanted to talk about just kind of like what the job is, what you're expected to do. And, this is kind of like what are the skills you need for, to be a data engineer, basically, right? So you need to know databases. So whether they're relational or non-relational databases, you need to know how to do some data modeling, some programming, so Python, Java, Scala especially. So Python and Scala are like kind of big. Java used to be big with tools like MapReduce, but I know Java is still used, but I don't think a whole lot compared to Scala, Spark, or Python. Architecture. Let's see. Tools like data orchestration tool, which I'm going to talk about. Airflow, for example, is one. You need to understand, these days, you need to understand cloud. Some companies are still on premise, but understanding cloud helps a lot. Communication, because you're going to communicate a lot with the analysts to ask them questions, understand what their needs are, have a lot of working session with analysts, and just be creative and a good problem solver. Yeah.
So what's Luigi and Uzi? This is interesting names.
I think Uzi is what you call it. It's the I forgot what it's a Hadoop, Apache Hadoop tool. 1 second. Yeah, it's kind of like Airflow. Yeah. It's a scheduler from old, like it's an old scheduler. So you can think of it as like an old Airflow. Yeah.
Okay.
Yeah. So these tools, I mean, I must say Luigi and Uzi are kind of like, old school now, but Airflow for sure is still used. So even Hive on some is still, I kept it here because some companies still use Hive these days, but not a whole lot. Spark for sure. A lot of companies use Spark.
Okay.
Yeah. Any questions? Okay. So
just to add on Hive, like us, we use Hive as a data lake.
Mm-hmm.
So we have data coming from different sources, gets extracted, transformed, and loaded into Hive.
Mm-hmm.
And then from Hive, we can run our machine learning algorithms to predict whatever is required. So we are using it mostly as a data lake than a traditional data storage.
That's a good point. I'll pull it up. I'll pull up Hive so people kind of get an idea. Yeah, I haven't looked at Hive in so long. Gosh. Yeah, so Hive, distributed fault-tolerant data warehouse system that enable analytical on a massive scale and facilitate reading, writing, and managing petabyte of data residing in a distributed storage. Yeah. So this is Hive. I can put the thing in the chat if people want to take a look. But yeah, as Baron mentioned, his company still uses Hive. A lot of, like I said, a lot of companies still use Hive, but they're all like, it was really big, I would say, like started 10 years ago, until cloud came in and kind of took over everything. Yeah. Okay. Okay, so now we're getting close to the demo part of things. So I built a small pipeline. So basically, the use case is that we have a company, company X, that needs a file from another company, and once that file comes into the environment, we want it to be ingested and then put into a table, basically, in BigQuery. So I'll show you the quick architecture. So we have the file that is outside of our environment coming into cloud storage. I'll show you what cloud storage is. And then once the file drops here, automatically there's a piece of code that is called that says, oh, the file came, let me call the processing now. So this tool here will basically start the processing, and then when it's done, when the processing is done, it loads the data here in BigQuery. So all of this is kind of like automatic in a way. Yeah. So any questions on this? Like it's a fairly familiar, not familiar. It's a frequent use case where you have a file come in, calls a function, and then function calls an orchestrator, and then the file is loaded into another table, basically. So it's a very simple use case that happened. And like I said, all of that is kind of like in an automated way. Now I'll show you what cloud storage is. Actually, sorry, that's not the one. Can you see my screen? So actually, sorry, this is not the one I was trying to show. I was trying to show something else. Sorry about that. Okay. Can you see the bucket?
Yes.
Okay. So in Google, we have, again, what I was talking about. This is where you can store data or store files. So this is what you call a bucket. And Amazon is called S3, Amazon S3 buckets. And in here, Google is called cloud storage. And in Microsoft, I think it's called blob storage. So in the bucket, you can kind of think of it as like a kind of like a folder structure, but small objects. So in the bucket, I have in a storage, cloud storage, I have a bucket called the demo. And then in the demo, I have two paths. Input, which is where I want the file to come in. So when the file comes in here, that function that I have will know, oh, my file came in, then I can start now doing the processing. And then once the processing is done, we cannot leave the file here. We have to move it somewhere else. So this is why I have another folder called archive, which will have the file, like the file that came in. And typically, because usually the file will come with the same name, the idea or the pattern is to always append like a timestamp to tell you, which would tell you what day that file came in, so that if you move another file of the same name, it's not going to overwrite this file, basically. But because this is a demo, I didn't do that. But in reality, when you're working in an office, in an enterprise, you need to do these kind of things. You need to kind of like append like the timestamp, which is one way of doing it, to make sure that the file, if another file comes in, it doesn't basically overwrite this file, and you have history basically. So that's cloud storage. That's the first thing in our architecture. Then after cloud storage, we have what you call the cloud function. So I'm gonna go to the cloud function now. Okay, so this is a cloud function. So basically what it is, it's a small Python function that does one thing, basically. It could do multiple things, but typically you want it to only do like one thing. And I call it trigger flow, and I'll show you the code for it. So basically, I won't get too much into the code, but so this is basically the code that it executes. So again, to explain what a cloud function is, it's a function that gets called based on a certain event. And for our particular use case, the event is a file in the storage, and that storage that I showed. So this is the file. So I will call this. I will get into the DAG later, but basically this is the code here.
So sorry, real quick there, Aziz,
Mm-hmm.
if I may.
Yeah.
So the idea is that every time the file loads, it triggers the function, basically, right?
Exactly.
Okay.
Yep, that's exactly right. So it's based on it's event based. So as soon as the file drops, the function gets called to do something else. Yeah.
So it's the equivalent of Lambda functions in AWS.
Exactly. Yep. Ben has used more Lambda functions, right? Ben, it's the same, right? Like it's the same idea, right?
Yeah, it's the same.
Yeah.
But AWS created this thing.
Yeah. And then Google copied.
Yeah, Google copied.
Yeah. It's nice. It's really neat.
Yeah, the advantage is that the use case that Aziz is showing, like we can easily imagine like thousands of companies sending that one file to the same processor. So like it means that thousands of cloud functions can be started and do the processing in parallel. That's the main advantage for that.
And at a cheap price.
Yes.
Cloud functions are pretty cheap.
Yes.
Yeah. And obviously you can use different languages to write the cloud function.
Sorry, Aziz, right there. When you say it's cheap, I'm assuming it's cheap relative to something. I was wondering what that something is.
Yeah. Oh yeah. It's cheaper related to some other things. Yeah, it's in terms of like cloud resources, and what it can do. It's fairly cheap, compared to, like, if you had to do it a different way, is what I'm trying to say.
And the main reason why it's very cheap, because it leverages the serverless technology. So instead of spinning up computing units or a virtual machine or whatever to run that specific function, it's coming out of the box from the cloud infrastructure without the need to provision any server for that. So it's serverless by itself.
Mm-hmm. Yep, that's a good point. Okay, so we saw this. Any other questions? Okay, so we saw the storage, we saw the cloud function. So again, the cloud function calls something that we call Airflow. It's a tool. So you can see trigger DAG, and I'll show you what it is in a second. So it calls another tool that is called Airflow/Composer, right? And I'm going to show that to you next. So Composer. So Composer is a orchestration tool. And it's a little tricky to explain what an orchestration tool means, but basically what this tool does, and if you can think of it of the name, right? Composer. So like a music composer, right? So the music composer tell the violinist and the piano and the whatever tools are in the orchestra to basically, do what they need to do. The composer itself does not do the violin. It doesn't do the piano. He's orchestrating how the entire thing happens, how the entire orchestra needs to play the piece, right? So you can think of it as what this tool does. This tool is basically orchestrating how different parts of the processing needs to happen. So when I say the processing, and I'll show you what I mean by that in a second, but that's the only thing that it does. So it basically calls certain things, like it could call like a bash command, Python code, SQL code, and you can chain them all together to do your pipeline basically. So I'll show it to you. So so Composer, we have and then it has a nice little UI that I'm gonna show. You opened it in a different tab. Give me a second here. All right. So this is the UI for Airflow. So when I say Airflow or Composer, it's the same thing. So Composer is just the Google version of Airflow, but there's actually a tool. It's called Airflow in reality. So this is our DAG, which stand for directed as I can't figure out the second word, acyclic or something like that. Graph and I'll show you what basically it has.
Directed acyclic graph.
Acyclic, yeah. I can never remember the second word. Yeah, it just means that if we go inside of it. Oh, today is a little slow. See, so I have 2 steps in it. You can have many steps. Oh, sorry. When I say step, I mean these. So this is a step or task. So this is another step, or it's technically called a task. So I remember, as I was mentioning to you, right? So Airflow basically orchestrates or manages tasks. So for this DAG, which is the name of a pipeline, you can think of it as like a pipeline. For this pipeline ingest Google Trends, I have two tasks. Well, the first task is to load the data from the storage into BigQuery. I'm going to show you what BigQuery is later on. And then after I do that, I want to archive the file. So take it from the input and then put it into archive folder. So basically, when you run this, it will run this one first and then this one second, and automatically. You don't have to touch anything, you have to do anything, it's automatic. And I can show you what's inside. I don't know if this one is going to show anything, but you can see the configuration here. So it looks into the bucket, it finds that file, and then it loads it into this table. And I'll show you the table in a second. So any question on Airflow? I know this is kind of like, if you've never used it, it's might be going a little fast here because we're not getting into too much details. This is mostly an overview, but any questions on this? Ben, anything you want me to, that I'm not, that I missed that I can maybe touch on?
Yeah, maybe in other terms, it's as if it's a factory flow, and then there's steps in the manufacturing of a product. You know,
Yep.
so the first step, like one worker will do something, then put it in the conveyor belt for the next person down the line to do something else, you know, and so on until the final product is delivered. So essentially, that's what our Airflow is.
Yeah.
So.
Okay. Next is I'm gonna show you BigQuery. So again, this is the processing step. Again, like I said, you can add, for example, you could even add one step after, in between here to say, actually, no, it will be after this archive file. Like, oh, now that the data is loaded, do something else with that data. You could do like data quality checks, for example. And then after that's done, you can do something else. You can do something else. You can do something up until you're done. So you can add more tasks to it. Okay, now let's get to BigQuery. All right. So this is BigQuery. So BigQuery is just a it's a data warehouse where you store your data. And so which part was that? Like, you know, the storing and the analysis. You know, so you can think of it as like it's kind of like a database, but not your traditional like what do I say that the like MySQL, for example, database. Not like that. It's not for like transaction. This is more of a data warehouse. And the file that I showed you that we are ingesting basically comes in and lands in this table, right? So you can see we have I'm going to show you the file we're going to run, but basically we have actually I should probably talk about the file that we're loading in a second here, but basically this is what, you know, we're loading the data here in the table here, Google International Trends. Now let me show you the file that I basically loaded. Where can I find it? Give me 1 second. Okay, bear with me. Can you see?
Yeah, can see.
Is it clear enough?
Yeah,
Okay.
everything is readable.
Okay. All right. So this is the file that we're loading. As you can see, the first record, the first line has the what we call the schema. So we have term, score, rank, refresh date, region name, region code, week, country name, country code. So you can think of it as like an Excel file. And then we're gonna load this. So this, like the example that I was using, someone from outside sending us this file because we needed to do something with it. Like we needed to do our processing, right? Or to do some analysis. So they send us this file. But the thing is, we need to know the format of the file first, right? So usually in an enterprise, they're gonna send us a test file, and then we're gonna open the file. We're gonna take a look at it. We're gonna see, oh, it has 1, 2, 3, 4, 5. Like, is it 9 columns? Oh, we know it has 9 columns, so we need to make sure our database or BigQuery has 9 columns for it. These are the names of the columns. So we could decide to keep these names, or we can change them, but usually you keep them. You keep the name so that it matches the file. And then, yeah, once you have that information, you can now start to build your pipeline. So any question on the file, now I can go back and show you kind of like the process, right, real quick.
Yeah, so it looks like one of the columns has a bunch of holes. I think the second column, like score.
Has a bunch of holes.
Yeah, can you bring it up? Okay.
Yeah, 1 second.
Yeah, like the second column, like score.
Mm-hmm.
So after 100, it looks like there's nothing.
Mm-hmm. Yeah, that happens. So that means that like these records don't have data, which goes back to what even Baron was saying, right? So this is a good catch, actually. So these fields, these rows don't have this score, right?
Mhm.
So that means that somewhere along the lines, like these rows don't have that information that's coming in. So you can either decide, do I keep these rows, or do I put in a score that we agree upon with the analyst, or do I remove those rows because it does not have this information, but you can still load the data.
Yeah, or put the mean value or
Yep.
with the row. Yeah.
Yep. Yeah. So that's the data quality checks that you can do. Data quality, or to do that.
Yep.
Any questions? Today there's not a lot. I hope it's all right. So let's go to. I'm gonna go back to BigQuery real quick. So what we're gonna do right now is, you can see our table. Our table has data, right? Our table has data in it. So you can see I mapped it right here with all the columns that it has. And then you can see preview of the data from what we loaded, right? It has about 94,000 rows. What we're gonna do, we're gonna delete those rows. Um, empty it, and then we're gonna reload it again. All right, so you see statement remove 94, blah, blah, blah rows. So if you go back here, it should be empty. I probably need to refresh, but you can trust me on this, it's empty. So I don't want to refresh and lose. Actually, I can do it.
Yeah, there's a refresh button on the right.
Yeah. Where are you? Where is it?
Now, if you go back to the previous view, yeah, you see on the right, there's a refresh.
Yeah. Perfect. See, empty. All right. So now we're gonna run our cloud. We're gonna run our pipeline, because we have a small pipeline that we created in Airflow. We're gonna run it now. What are we gonna do first? We're gonna go to. Sorry, I have to always like stop sharing and then share another tab. That's the way with. I can't bring like a window. It would have been easier like that, but it's okay. We'll go back to our file. So we'll move. So again, you can see input is empty. In order for the function to run, we need to bring the file here. Currently, it's in archive, right? So we'll move it. Move. But in reality, that's not how it works. In reality, the file will come automatically in the input, right? So, but because it's a demo, we can do it manually. Hopefully that issue doesn't happen with today again, than what I was telling you about. But we'll see. All right, we'll move the data. So the data left archive. The data should be in input now. You see it's here. And then if we go back to Composer real quick here. Hopefully, I think it's going to be done before I even get there. Composer. I need to find a way. Yeah, it finished even before I was even able to get. So, yeah, because it's so fast, and it's a small pipeline, so it already ran, by the time we even got here. So to tell you that it already ran, let's see, go here. Let me make sure that it actually ran. Give me 55, what 152? That's not right. Actually, sorry, 1 minute. That's the beauty of doing demos, man. Like, things don't always go the way you want. give me a second.
Yeah. Maybe do you want to enable the auto refresh on the right?
Yeah, the it's yeah, it should be enabled. I just want to see. I can go and take a look at the table to see if it actually ran, but yeah, it definitely ran because I gotta go look at the table real quick. Oh no, it did not run because the table is empty. So my cloud function did not trigger, and I need to figure out why. Bear with me a little minute, a quick second here. Okay. Yeah, I know why. Yeah, I know why. So I will show you something real quick. I know why my cloud function did not run. So currently the cloud function, so I was doing some testing the other day, right, to prepare for this. And I made a quick change actually yesterday, but I forgot to make the change in the cloud function. I'll show you why. So we can edit the cloud function. So you can see currently the cloud function is looking at this bucket, but in reality, the path is a little different actually. So I need to have a look here, if you can find it. I need to set up a bucket. And what as you can see, you can have like up to 3,000 instances. I need to make sure it's all good. On time. Deploy. Okay. So it's going to deploy the cloud function again. If it doesn't trigger it, I will trigger it manually, which is, I mean, it's okay. But in reality, like when the file drops, it should basically trigger and call that DAG that I was showing. Any questions so far on this? I mean, my point, my goal is, even if the technical part is not really clear, at least understanding the general idea of how building these pipeline work, and what it entails, and some of the tools. because different companies or different use cases will have different architecture. Okay, so it's deployed. Let me take a look at the logs. Bear with me here. I just want to double check something in the logs here. Why is it not finding the URL? That is the beauty of doing demos. This thing worked like just before the call. Anyways, all right, let's pivot. So the cloud function gave me my Miss Petit Vélo. So I will pivot real quick here and we'll go back to the DAG. So theoretically, what should have happened was that the cloud function should have called this DAG to start this process, but we can start it manually. So we'll trigger it. So you see, now it's doing the first process. So that's good. So that one's done. Now it's going to archive the file. And that's done. So that was quick. Usually, when you're in enterprise, it could take a little longer than this, but this is a demo, so it was fairly quick. So the first test is we'll go and take a look at the table. So I will stop sharing and then share again where the table is, create a result. All right. So you guys remember the table was empty. Now, if we refresh, I should have data. There you go. So we loaded and again the same number of rows, 94,743. So the table has been reloaded. So that's the first test. The second test is to go make sure that the file actually moved from that input folder that I was talking about and went to the archive folder. So sorry again, I'm gonna stop sharing and then share it again. So as you can see, if we go into input, it's empty. We go to archive, you see the file was there, and you see it was created April 22nd at 11 a.m. So it's 11. So yeah, I mean, that's really what kind of like how you can put together a pipeline. I will go back to BigQuery and kind of show you the type of things you can do. So I had a small query kind of set up. So for example, so I have this going. I wanted to see like for the data set that I have, all the terms that are like popular. Don't mind this query, it was a quick query that I wrote, but you can see a lot of these like, so basically these are the region. So Berlin, I don't know what Holland is, maybe like a soccer team or something. But you can see a lot of people like to search for Real Madrid, that's in China. Come on. to go down, I think this is different. I don't know if this is Russian or what, but to go towards the end, you can see like England and Paris, Brussels, Celine Dion. So basically what this data set is that all the people, what people search on Google, depending on where you are, they basically give you like data about it, like information about it. So yeah, I think that's really all that I wanted to share. We did go through quite a bit of tools. The one thing that I wanted to, I guess, talk about that we did not really showcase here a whole lot was the dashboard side of things. So you could do more transformation here. Basically, you can write queries to do more transformation on this data, and then add it as another step in the Airflow, and basically that becomes again another transform data, and you can now put a dashboard on top of it, so like Tableau, Looker, and then basically like have a Tableau developer build like a dashboard on top of that and showcase. So, but that would have been another endeavor basically, because you're gonna have to get the Tableau license, all that stuff too. So I mean, that's really what I wanted to showcase. I don't know if anybody has any questions, if you want me to touch on anything else. Sorry, the cloud function kind of like puked on me, but I don't have time. I don't want to go through the troubleshooting, but just trust that it should have triggered and then called the DAG basically, and it should have loaded the data. Any questions?
I don't have any questions, man, but I want to thank you. That was very, very interesting. That's a nice introduction to the thing, and as usual, it's not as scary as you might think it is on the other side of it. So thank you for that.
Yeah, definitely. Yeah, thank you for coming up. Yeah, Faisal, go ahead.
Yes, I have a question. What is the difference between a data engineer and a DevOps engineer?
Okay, so data engineers is like what we just did, right? A lot of the building pipelines and dealing with data. So DevOps, and Ben, please add if I miss something. DevOps does more of the infrastructure type of thing. So for example, right, all the tools that I showed, right? So Cloud Function, BigQuery, the storage and all that stuff, right? It could be done like the putting this infrastructure together can be done by a DevOps engineer, but it would more likely be done by a cloud engineer or a cloud architect. What a DevOps would usually do is to build pipelines where you can use that to deploy code. So for example, if you're a software engineer, right, and you are using, for example, Azure DevOps or GitHub, you write your code in your local machine, you use your Git command, you push your code into the remote servers. If you want to do continuous integration and you want to do continuous development and continuous integration, CI/CD, the automation part of that side. So when you push your code and then your code gets built and then gets deployed into the server, and then you can go and take a look. Oh yeah, okay, I made this change to my code. This is what it looks like. So that automation that is behind the scene, making sure that production servers are up, making sure QA servers are up, making sure dev servers are up. That is usually what a DevOps engineer does. So operations, so like operations, the developer for the operations side of things. Yeah.
Yep.
Yeah.
So can a data engineer easily? Oh, sorry, go ahead.
Oh, I was just gonna add to what Aziz just said. So if we take the use case that Aziz just demoed, like in some companies, they have like maybe some restrictions or policies that can prevent them from using like a cloud provider like Google, but yet they still have the same use case, of processing data at scale, right? So in that case, the DevOps engineers will be the ones creating the infrastructures for the. The DevOps will create the infrastructure for the data engineers to be able to do their work. Like, for example, Google has cloud functions. Most likely a DevOps engineer will set up like a Kubernetes cluster with Knative, to have a similar functionality, right? And it's not just putting together the infrastructure so that others can work. There's also the troubleshooting part. Like, for example, the fact that the function didn't trigger in a real setup with DevOps in a company, this would have been a problem for the DevOps engineer to figure out. They will receive an email like, hey, the function is not triggering, do something. So there's this aspect of that. And also, when it comes to data in general, like a lot of people working in the field usually come from the business side. Like all the analysts and things like that. But yet they require some infrastructure to work. So there's one aspect of data where people, they don't really play the role of data, like data engineers and stuff, but they have to be knowledgeable enough into the tooling, especially for how to set it up. So all this will be considered DevOps. So, yeah.
Yeah. Thank you, Ben.
Thank you.
Any other questions? Cool. Well, it's 11:10. Yeah, that's really all I had. Appreciate you taking the time to come in and listen to us this morning. Baron, go ahead.
Yeah, just wanted to add on top of what you guys already explained on DevOps. So DevOps is actually kind of an acronym which is made of two words. Dev is related to software development and ops is related to IT operations. So the role of a DevOps engineer is to integrate and automate the work of software development and IT operations to facilitate the delivery of software products in an enterprise environment. So the role actually derived from the name itself, DevOps, development and operations.
Yep. Exactly.
I saw in the group I saw Sifiso. Sifiso, are you South African?
A little close. I'm from Botswana.
Oh, you're Mutswana.
Yes, I am.
Okay.
It's a South African name, so I hear you.
Yeah, Dumelang.
Dumelang.
That's awesome.
Nice.
Yeah. Cool. Any other questions?
Any thoughts? Any questions? Yeah. Anybody has any thoughts? Any questions? Anything to say?
And if you want to present.
Yeah, if you want to present, yes, definitely.
All right.
Cool.
Okay, so yeah, this was a quick overview of data engineering. I hope that, and it's an ever-changing field, I can, before we part ways, I can say, like, I remember when I actually did some data science work for some time, and then I realized after going to a couple of projects, I realized that data engineering was a little bit more. There was a lot more opportunities as opposed to data science, especially in my region. So that's why I kind of transitioned more into data engineering. So I did that for it's like 3 years, 4 years. Fun, yeah. Built a lot of pipelines, and yeah, it was fun. I learned a lot of tools. You definitely learn a lot, a lot of SQL, like to write these queries, getting the tools together. So it was fun. Yeah.
Yeah.
So. All right.
That's nice.
Yeah. All right. Well, then you all have a good Saturday. So have a good weekend. Thank you again for coming. We'll send the link for the next talk in 2 weeks. So yeah, hope you learned something.
Oh, maybe a quick question. Is there anything in particular that you guys want to see next time?
Not really, but I think it's better to send the form like you sent the last time. Like we can vote on it. Yeah.
Let me see. Let me see if I can do that real quick. Okay. So I added one in the Q&A. Oh, wait. I'm supposed to do polls. Let me see what else here. Okay, I sent the votes. Yeah, because I mean,
definitely it's gonna be DevOps. I already vote DevOps.
DevOps.
DevOps?
Yeah, DevOps.
That's a denser.
Okay.
I just started on DevOps first. It's gonna be great if I can get some more.
Okay. Yeah, it could be like a quick overview of DevOps, like the CI/CD and
exactly.
Yeah, GitHub, Git.
Yeah.
We'll figure it out.
Yeah, I can do that. I'll come up with something small because last time the stuff I was showing was for an existing project, so there was too much going on.
Yeah.
I'll try to do a small thing like from scratch. Then we can see. Yeah. Did you have a preference for GCP or AWS?
AWS.
Perfect.
I wanted to know whether
if it was GCP, Ben would have put it back at me. Don't get me wrong, I like AWS, but GCP, I know a little more about GCP.
Yeah.
Okay. Yeah, I'll work on that. Yeah.
Got it.
Yeah, man.
But I'm not alone. Like nobody wants something else. Like I just share my thought.
Yeah. I mean, the poll is there, so.
Okay.
No, honestly, my little journey right now, I'm in the data space. So anything data related is what it is. I was telling Ben the other day that my next mission is machine learning. So, but anything data related, honestly, because knowing myself in a few years, I want another challenge, So it's a good thing to have a reference back and say, hey, I saw a bit of data engineering there. That really goes a long way than most people realize, because at least I have a base and a vision now. So anything data related for me is what I want.
Yeah.
Cool beans.
Yeah. Yeah, we have to demystify that stuff.
Yeah. Yeah. Yeah.
Yeah, cool.
Okay. Baron, tu as la main levée encore aussi, mais c'est bon. Looks like you have your hand up, Baron.
Today?
You still have your hand up. Are you good, or do you have another comment?
Oh, sorry, I forgot to take it down.
Okay, no worries. Just wanted to make sure.
Okay.
Yeah.
All right. C'est bon? It's good?
Yeah. Yeah,
All
thank you very much for coming, guys.
Yeah, thank you all.
Thank you so much for hosting this,
Thank
guys.
you,
This was
guys.
amazing.
Thank
Yeah,
you.
good
Thank you
work,
very much for hosting.
Yep. Bye.
Thank you. Thank you. See you next
Bye bye.
time. Bye-bye.